Now, next simple project is onboard diagnostic data analysis project. You will see how we are going to go about it. Now, here is a detailed breakdown of real world live OBD data analysis project that aligns with your interest in vehicle diagnostics. Okay, understand this word carefully. Live OBD data analysis. We are going to analyze the live OBD data. All right. Now the project title is ESP, which is a hypothetical name, ESP32 based vehicle telematics and OBD2 data logger. The project combines live OBD2 data acquisition, GPS tracking, and remote data visualization using a ESP32 microcontroller and a CAN interface and a Raspberry Pi server. It is ideal for fleet diagnostics, driver behavior analysis, and emissions monitoring. Now, talking about the system architecture overview, talking about the component role and ESP32 development kit reads OBD2 data via CAN and GPS coordinates. Now, CAN module interfaces and vehicles CAN bus through OBD2 port. Now, talking about the GPS module, captures location and timestamp data. And talking about the next component is SD code module, card module stores trip data locally. Now, Raspberry Pi, it hosts Flask API and PostgreSQL data base for data ingestion and storage. All right. Now, talking about the web app, visualizes trip data using Google Maps and API. So these are the various components and these are the respective roles. Now, what is the data flow summary? First step is data acquisition. This ESP32 sends parameter identification request, example RPM, speed, fuel trim via CAN and receives the responses and logs them with GPS coordinates. All right, local storage. Data saved to card data.txt on SD card and each trip session is tagged with vehicle identification number and timestamp. Now talking about the data upload, when vehicle returns home within 30 meters of the preset GPS, ESP32 connects to Wi-Fi and uploads data to Raspberry Pi via Flask API. Now talking about the server processing, Raspberry Pi stores data in CSV or Postgres SQL. And talking about the daily script calculates idle time, max speed, and fuel efficiency and trip duration. All right. Now talking about the visualization, web app fetches data via API, displays trip path and metrics on Google Maps. Okay, so this is the data flow summary. I request all of you to go through this data flow summary a couple of times so that you can clearly understand the actual workflow of the data. Okay, the actual flow path of the data you will very clearly understand. Now talking about the sample metrics, what are the various metrics? First is in this table we are going to see the parameter, the source parameter identification and also the purpose. Okay, for example, engine RPM. The source PID is 0/0C, detect aggressive acceleration and vehicle speed and 0/0D and monitor speed violations. Now talking about the throttle position, 0/11 analyzer driver input and fuel trim 0/06 and 0/07 evaluate engine efficiency. Now talking about the coolant temperature 0/05 and check thermal health. Talking about the GPS coordinates, the external, the source PID is external and the purpose is to map trip route and geofence boundaries. All right, these are the sample metrics. Now talking about the cybersecurity consideration, this project can be extended to align with WP29 and ISO SAE 21434 by encrypting data during the upload and second is authenticating firmware updates to ESP32, logging and diagnostic access attempts, and implementing anomaly detection for spoofed PIDs. Now, talking about advanced use case, the driver behavior profiling, detect harsh braking and rapid acceleration and swerving. All right. Next is usage based insurance. Score drivers based on real time metrics and predictive maintenance, flag abnormal fuel trim or temperature trends, and fleet management, aggregate data across the vehicles for centralized monitoring. Okay, so these are the various use case in which the data is thoroughly analyzed. Okay, thank you.